Hi there, this is Mr. Lee. This video focuses on the solving of the quadratic inequalities, and here we go through two types of questions that you might encounter along the way. In the first type, in part A, we are just solving a given inequality, and here you find that there's actually a few steps that you might want to follow, and we claim that if you follow them well, right, you should not be getting these questions wrong. So the first step when it comes to solving inequalities is to ensure that you bring all the terms to one side of the inequality so that you see 0 on the other side, like this. So here we bring the negative 2x squared term and the 5x term over, and you see that this becomes a quadratic expression that is more than 0. Then step 2, right, you try to factorize the quadratic expression completely. In this case, it is possible, right, nicely factorizable to 2x minus 1 times x minus 2. Okay, where students usually will go wrong is actually over here, where you treat this as solving a quadratic equation, and you write something like this: 2x minus 1 more than 0, or the second term, x minus 2 more than 0. Okay, this is a big no over here. Okay. When it comes to solving inequalities, do not do the same way as how you solve a quadratic equation. Instead, actually what you should do, right, is to sketch the corresponding graph, or at least try to visualize it, right, before you actually conclude what is the range of values of x. So here, right, being a quadratic expression where the coefficient of x squared is positive, right, is 2 over here, it's a U-shaped smiley face. And the point about factorizing over here is so that you know what are the x-intercepts for the graph. So here we actually just draw a graph, U-shape, cutting through the x-axis, and we know that x-intercepts are half and 2. From the graph, what do you do? Well, you now look at the inequality you had in the previous step. You want this quadratic expression to be more than 0. So now you look at where the U-shape is above the x-axis. Right, this is where the y values are more than 0. And then from there, you read off the corresponding range of x values. And here we conclude that x must be actually less than half, or x must be more than 2. That settles part A. Part B is actually a more rare kind of question, but it's actually not uncommon when it comes to school exams. Okay, this is actually where you have to work backwards. So now we are told that you have a quadratic expression, and this expression is less than 0 only when x is between 4 to k. Well, how do you find your unknowns p and k over here? Okay, the trick over here is to actually sketch a graph. In this case, well, this is after all a quadratic expression, and this is actually where the coefficient of x squared is 3, which is a positive, and that tells you that it is a U-shape. And the question over here says that it is possible for this quadratic graph to be below the x-axis. So we'll just draw a graph cutting through x-axis as a U-shape. And question says that this is negative only if x is between 4 and k. So we might as well mark out points over here. These are exactly the region, right? This is actually exactly the region where the curve is actually less than 0, between 4 to k. And with that, we actually try to find our values by doing this. We know that in this case, what the x-intercepts are. So we can actually express our quadratic expression, right, in the fully factorized form, something that you might have seen in a previous video. And in this case, looking at the coefficient of x squared, you see that you need to have a 3 over here to balance things out. Okay, so on top of the factors x minus 4 and x minus k, which corresponds to the x-intercept, you need to have a 3 there to balance things out. And then what do? You now expand out fully, and grouping the x squared term, x term, and constant term separately. And then you multiply in everything so that you can get the expression of the form ax squared plus bx plus c. So what do you do now after that? Well, all you need to do is actually to compare the terms. The first thing I'll compare is the constant term. With that, you see that 12k has to be 84, and that gives you your k value. If you actually compare the other one, which is the x term, you see that the coefficient of x is exactly the same. So here, you find that, right, your p is just your negative 3k minus 12. And since k is 7, you get your p value for free. So that concludes our video for today. Hope you find it useful, and we look forward to seeing you in our next video.